Okay, let's go ahead and look at a f prime and f double prime problem, which is what I call them. But anyway, if you look at my notes or look at the previous video that deals with f prime and f double prime problems, this is just about all the stuff you'll need to find out all of the stuff about these problems here, and or to answer all the questions anyway. And let's go ahead and kind of take a look at the first problem here. It says the figure above shows a piecewise function of f, and g is defined by g of x is equal to the integral from 2 to x of f of t dt. Does g have relative min, relative max, or neither at x equals 10? Okay, so I see the word relative min or relative max. Whenever you see the word relative minimum or maximum, you're going to do you're going to take the derivative and set that derivative equal to 0. So I need to find what g prime of x is and set it equal to 0. I know that g of x is equal to the integral from 2 to x of f of t dt. Now I need to find g prime of x, and g prime of x is equal to f of x, and I need to set f of x equal to 0. Well, what's f of x? Well, that's this graph. So let's do our line justification. So I know that g prime of x is equal to f of x, and the only value that we want to consider is x equals 10. And if you look at f of x, and at 10, the values before 10 are negative, because they're below the x-axis, and the values after 10 are negative also because they're below the x-axis. So that means the function g is decreasing from here to 10, and from 10 on it's decreasing also. So that means that at x equals 10, g has neither a min or max, because g prime is less than 0. The first derivative is less than 0 from, we'll say 8 to 10, and g prime is also less than 0 from 10 to 12. And that's our justification there. Okay, now let's go ahead and take a look at the b part. Does the graph of g have an inflection point of at x equals 4? So I see the word inflection point of g. So if I want to find g, the inflection point of g, that deals with the second derivative. So I need to take the second derivative and see what happens at 4. So I know that g of x, and I'm just repeating this stuff, is equal to from 2 to x of f of t dt. So that means g prime of x is equal to f of x, doing the second fundamental theorem of calculus, or the first fundamental theorem of calculus, whichever you want to call it. Now g double prime of x is equal to f of x. I'm sorry, f prime of x, because we're taking the derivative of both sides. Now what I have to do is I have to see what happens at 4. So if I look at g double prime and at 4, so here is the value 4. Now since we're looking at g double prime and we're looking at f prime, so I want to look at f prime. So that means the slopes, you're going to have to make the connection that the derivative of f is going to be the slopes of this graph. And the slopes from 2 to 4 are positive. And the slopes from 4 to 6 are negative. So since we're dealing with the second derivative, I know that it's concave up here and it's concave down here. So that means that g has an inflection point at x equals 4. Now they like the word because now we have to see what happens here. Now used to you can kind of get away with it. You could say because g double prime is greater than 0 from 2 to 4, and g double prime is less than 0 from 4 to 6. You can't do that anymore. You have to use the first derivative to your justification. And the way you're going to write it is you're going to say g prime is increasing from 2 to 4 and g prime is decreasing from 4 to 6. So there's your justification. All right. Okay, let's look at this next one here. This next one says find the absolute value, the absolute minimum value and the absolute maximum value of g on the interval from -4 to 12. Notice on this it has from -4 to 12, but we're including the endpoints. So if I see the word minimum or maximum of g, and I know that g of x is equal to the integral from 2 to x of f of t dt, I have to take the derivative and set it equal to 0. So g prime of x is equal to f of x. Now I have to set that equal to 0. So if I want to set this equal to 0, well, what's f look like? Well, that's this graph. So I need to find all the zeros. In other words, all the places that it crosses the x-axis at, or touches the x-axis. So g prime is equal to f. If we do our line justification, we're going to go from -4, and at -2, from -4 to -2, f is negative because it's below the x-axis, and from -2 all the way to 6, it's positive because they're above the x-axis, and from 6 to 10, negative, and from 10 to 12, negative. So what that tells us is that g is decreasing here, then it increases, then it decreases, and then it increases. So what's that tell us? That means that g right here at -2 can have a relative min, and over here also. And g has relative min here. Alrighty, so now I know that one of these two places has to be your absolute minimum. So I'm going to make that statement. So I can say g has absolute minimum at x equals -2 or x is equal to 10. So since it wants that, I need to either find g of -2 and find out what that value is, and I need to find g of 2 and find out what that value is. So let's find out what g of -2 is. So what I'm going to do is I know that g of x is equal to, I'm going to write g of x is equal to right here, the integral from 2 to x of f of t dt. And so what I need to do is I need to replace this x with the -2, so we integrate from 2 to -2 of f of t dt. And since that limit is smaller than, since the upper limit is smaller than the lower limit, you can flip them around and it becomes a positive of f of t dt. And so now I just need to integrate from -2 to +2. So from -2 to +2, that's a triangle. And so to find the area of this triangle, it's going to be 1/2 the base times the height. The height is 4, so this is going to be 1/2 the base is 4 times the height, that's 4, so this is going to be 8. And for our intents and purposes, let's just go ahead and find the area of each one of these triangles. This triangle is also going to be 8. This triangle right here is going to be 4. This is going to be 8. And this is going to be equal to 4 here. So now that we have that business, if I integrate from -2 to +2, from -2 to +2, that value is 8. but since we have that negative in front, so g of negative 2 is equal to 8. Now I have to find out what g of 2 is. Well, I know that g of x is equal to this, so if I just integrate from 2 to 2 of f of t dt, since those limits are the same, this value is going to be 0. So the absolute minimum value is going to be negative 8. So g has absolute min at x equals negative 2 and min value of negative 8. Now it also says I need to find the absolute maximum value. So the absolute maximum can occur here at 4, then it decreases, increases. It can occur here at 6, or it can occur here at 12. So I'm going to make that statement. I'm going to say g has absolute minimum at x equals negative 4, or x equals 6, or x equals 12. And I have to find all of those minimum values. So I have to integrate from 2 to negative 4 of f of x dx. I guess they're using f of t, so this is g of negative 4. And again, since that limit is smaller than this one, I'm going to switch them around. And I'm going to go from negative 4 to 2 and have the negative of f of x dx. And so if I integrate from negative 4 to negative 2, this value is a 4. I'm sorry. It's going to be a negative 4 since it's below the x-axis. So we have a negative 4 here and a negative here, so this is going to be a positive 4. So g of negative 4 is equal to positive 4. I'm going to do the exact same thing with 6. I have to say find g of 6. That's equal to the integral from 2 to 6 of f of x dx. So if I integrate from 2 to 6, that value is 8 because that's the area above the triangle, above the x-axis rather. So g of 6 is equal to 8. And now for the last one we have to find g of 12. To find g of 12, I have to integrate from 2 to 6 of f of x dx. This is what g of, sorry guys, g of 12 is equal to the integral from 2 to 12 of f of x dx. So I have to integrate from 2 to 12, so I have to find the stuff that's above the x-axis and subtract the stuff that's below the x-axis. The stuff above the x-axis is 8 minus 8 minus 4. So g of 12 is going to equal to a negative 4. So our absolute maximum, this should have been maximum, kids. Absolute maximum is going to occur at 6. So g has absolute maximum at x equals 6, and the value is 8. All right. I hope that helps with this problem. Anyway, talk at you later.